Okay, today's topic is the binomial theorem. Okay, we don't get into statistics really in here. I know you get them in Math 3. I know Mrs. Bybee does them. I know she's just working right now with her class on permutations and combinations, where if you have 5 options and you want to see how many different ways can you choose 2 if order matters or doesn't. So this is a little bit involved in that kind of stuff, but not too much. Okay. But first thing I want to do is expand x plus y quantity squared. Of course, nobody would dare say it's x squared plus y squared. I had a few of you do that on the last test. Okay. Of course, we just did this. It's x plus y times x plus y. Distribute, I get x squared plus xy plus xy plus y squared. Combine your like terms. I have 2xy plus y squared. Now let's expand x plus y cubed. Okay, which of course is x plus y times x plus y times x plus y. Now we just did this, which we got x squared plus 2xy plus y squared times another x plus y. So distribute your x squared. I'm going to get x cubed plus x squared y. Distribute your second term. I'm going to get plus 2x squared y plus 2xy squared. Distribute your third term. Plus xy squared plus y cubed. Now combine like terms. Let's see, I have x squared y, so I have plus 3x squared y. Then here I have 3 of those, xy squared and a y cubed. So there's x plus y quantity cubed. And let's do the fourth. Let me actually pull this up a little bit. Okay, which we know is x plus y times x plus y times x plus y times x plus y. So we need another x times x plus y. So I'm going to take the answer I have there. I'm going to multiply by another x plus y. Okay, so when I distribute my x cubed, I get x cubed, or x to the 4th, plus x cubed y. Distribute my second term. I get plus 3x squared, or x cubed y, plus 3x squared y squared. Distribute your next term. I have plus 3x squared y squared, plus 3xy cubed. Distribute your last term. I'm going to get plus xy cubed plus y to the 4th. Let's see, let's combine like terms. I have x to the 4th. The x cubed y's, I'm going to have 4 of those. The x squared y squareds, I have 6 of those. xy cubes, I have 4 of those. And finally a y to the 4th. So it takes a while. And just think about it. If you mess up one little power, the whole thing's wrong. So you have to be very careful. Okay, so what now if I asked you to find x plus y to the 12th? Now we just found to the 4th, and that was quite a bit of work. Think of how much work x plus y to the 12th is. Okay, so good old guy named Blaise Pascal, okay, worked on something called the binomial theorem to create a shortcut, which we'll get to in a second. But what the binomial theorem says, it looks very scary. Okay, I know it looks crazy. It's really not. If I have x plus y to any power, this right here is a combination. Now remember, you have a formula using factorials, r factorial, n factorial. Okay, and you also have a button on your calculator for permutations, combinations. You have that P and C. But that's what this is saying. You have n, choose nothing. Okay, so you have 5 items, let's say. How many ways can you choose nothing? Well, in this case, 1, right? And then you have x to the n power, y to the nothing power. Notice those are these numbers. Then you have n choose 1, which is x to the n minus 1, so subtract 1, and it's this power. Now you're going to subtract the numbers for the x and y. It's this formula here. It looks very scary. Okay? It can get confusing at times, but not when you use a shortcut. So this is the actual theorem, the binomial theorem, of how to expand polynomials and raise to power. But good old Blaise Pascal, a mathematician, and notice I have a poster in the back of the room with Pascal's triangle in there, he came up with a shortcut for these coefficients, these combination ones. So you don't have to do combinations. He came up with this. Tons of patterns in there. Okay? Pascal actually was a great mathematician, could have done great things, but he suffered from severe laziness. Okay? He would sleep all day, hypochondriac, died quite young, comparatively speaking, because he actually took a job that forced him to work, and he actually died from exhaustion, which wasn't actually that much work. But what it starts off with is you start with x plus y to the 0. Its coefficient is just 1, because anything to the 0 is 1. Then we look at the coefficients from just x plus y to the 1. Coefficients are 1 and 1. Then I look at the coefficients from x plus y squared, which we already did. Its coefficients are 1, 2, 1. So I want 1, 2, 1. Then I look at x plus y cubed, which we did. Its coefficients are 1, 3, 3, 1. Then to the 4th power, its coefficients are 1, 4, 6, 4, 1. And I can keep going, because you'll see once you have a few, there are tons of patterns, tons. Notice the outsides are always going to be 1s. Okay? The insides, they will go symmetric diagonally. But look here, the previous two numbers add to give you the one before it. Like 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So this next row will be 1. And add these, I get 5. Here I get 10. 10, 5, 1. So my coefficients for x plus y to the 5th will be these. Okay, notice if it's an odd power, you're going to have symmetry here. But if it's an even power, you're going to have that one number in the middle. It's still symmetric, but it just appears once instead of twice. So next one would be 1, 6, 15, 20, 15, 6, 1. Let's keep going a little bit. 1, 7. When I add that, I get 21, 35. That's a 20, believe it or not. 35, 21, 7, 1. Okay, let's go one more. I have 1, 8, 28. Let's see, 56, 70, 56, 28, 8, 1. And we can keep going, of course. But now let's actually use this. Okay? Just remember it starts off with x plus y to the nothing. This is first power, second, third. So if I want to explain x plus y to the 5th, I don't want to multiply that out. Here's how I do it. I look at my triangle. I go down to the 5th power. So 0, 1, 2, 3, 4, 5. This row right here is what I want. Those are my coefficients. So I'm going to leave a little room. I'm going to write my coefficients down. 1, 5, 10, 10, 5, 1. Left a little room. Because now what I do is I take this first term and I started off with its highest power, x to the 5th. X to the 5th, count down to the 4th, 3rd, 2nd, 1st, and that's really x to the nothing, which is 1, so we don't write. If I go back to the binomial theorem, you'll see why we count down. N minus 1, n minus 2, until it's nothing. So you're counting down. Now the other way, instead of counting up, I look at it as just starting at the other end. So I do the same for y, but I start down here instead of here. So this is y to the 5th, y to the 4th, y cubed, y squared, y nothing. Now in between are just pluses. And voila! That is x plus y to the 5th. Shortcut right there. Let's do another. We're going to throw in a coefficient. 3p plus q cubed. Okay, so let's first get our coefficients. cubed. So this is 0, 1, 2, 3. Here are the coefficients I want. 1, 3, 3, 1. So I'm going to leave a little space. 1, 3, 3, 1. Now take this first term. That is 3p cubed, 3p squared, 3p to the first, and finally 3p to the nothing. Now take this second term, go backwards. That is q cubed, q squared, q, nothing. Separated by addition. Now we just have to work on multiplying that out. Be careful, that is 3 cubed, that's actually 27p cubed. Remember, square before you multiply. Okay, don't make the first mistake, order of operations. So this gives me 9 times 3 is another 27p squared q. 3 to the 1, I just have 3 times 3 is 9p q squared plus q cubed. There we go. Just expanded 3p plus q cubed very quickly. Okay, you try. I'll go ahead and do this. To the 4th power. Okay, you can pause, of course, if you want to try it on your own. So pause the video, write down, try it. But let's go back into the 4th power. So it's 0, 1, 2, 3, 4. So these are my coefficients. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Now start off with m to the 4th. So you have m to the 4th and count down. M cubed, m squared, m, nothing. Now go backwards. You want 2n to the 4th, 2n cubed, 2n squared, 2n, and nothing. Make sure there's pluses in between. Very important. I will count off if you don't have those pluses in between because it is a polynomial. So let's clean it up. I have m to the 4th. Over here you have 2 times 4, so that gives me 8. M cubed n. Here do your power first. 2 squared is 4 times the 6 is 24. M squared n squared. 2 to the 3rd is 8 times 4, which is 32. M n cubed. And 2 to the 4th is 16 n to the 4th. Voila. Okay, let's throw some negatives in there. Really doesn't change, you just have to watch your negatives. Okay, so to the 5th, so if I go back to my triangle, my coefficients to the 5th power are down here. And if you have any doubt, the second number also tells you what your power is. See, second, 3, 4, 5. So 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, moving on to the next line, 5, 1. So start with this, go this direction, negative 2a to the 5th, negative 2a to the 4th, negative 2a cubed, negative 2a squared, negative 2a, and then nothing. Now go backwards, b to the 5th, b to the 4th, b cubed, b squared, b, put pluses between all of them. Okay, so let's clean this up. Negative raised to an odd power is still a negative 32a to the 5th. Okay, over here, negative when you raise it to an even power, it's still positive, because negative times negative times negative times negative make positive. So that'll give me 16 times 5, we get 80, so it'll be plus 80, a to the 4th b. Over here, that'll give me negative 8 times 10, so I'll get negative 80, a cubed b squared. Positive over here, that'll give me 4 times 10, so it'll be positive 40, a squared b cubed. Kind of run out of room, but here that'll give me negative 10a b to the 4th plus b to the 5th. So the negatives aren't any different, you just have to watch your powers. Remember, raised to an even, it's still positive. Raised to an odd, it's negative. So another one, p minus 2 to the 4th. So if I go back to my triangle, here's my 4th power coefficients, 1, 4, 6, 4, 1. So I have 1, 4, 6, 4, 1. So p to the 4th, p cubed, p squared, p, nothing. Go backwards, now this is negative 2. Negative 2 to the 4th, negative 2 cubed, negative 2 squared, negative 2. Put pluses between all of them because the binomial theorem is for plus expansion. So you can let that as p plus negative 2. So I have p to the 4th. That'll give me minus 8p cubed. That's positive 4 times 6, 24p squared. Give me negative. That'll be 8 times 4, so 32p. And here I have positive 32. Wait, did I mess up here? 8 times 4, 16, sorry. Extra 2 in there. There we go. So if you know Pascal's triangle, which you don't have to have memorized, it's easy to duplicate, it's just patterns of adding. If you know your triangle, you can expand these rather quickly. It's how when we were doing the difference quotient, I could do x plus h cubed really fast. I just knew it because I knew the coefficients. Okay, you should be able to too then. Okay, so last one, you can pause if you want to try the U try. Okay, a minus b to the 8th. So we went way down the powers here. So pause it and you can try it, but I'm going to go back and to my triangle. Oh, and I did go down just far enough. So 1, 8, 28, 56. Let's see if I can remember this. 1, 8, 28, 56, 70, 56, 28, 8, 1. Let me go double check just to make sure I wrote that down right. Oops. Yep, looks good. Okay, so now a is your first term, so I have a to the 8th, a to the 7th, a to the 6th, a to the 5th, a to the 4th, a cubed, a squared, a. Now this is negative b, so I have negative b to the 8th, negative b to the 7th, don't really have too much room, negative b to the 6th, negative b to the 5th, negative b to the 4th, negative b cubed, negative b squared, negative b. Now of course pluses between all of them. And notice when you have one negative, one positive, the signs kind of alternate. That can also help you check. That's just a to the 8th. Over here you're going to have minus 8, a to the 7th, b. And you're going to have plus, positive, that'll make that positive, 28, a to the 6th, b squared. Minus 56, a to the 5th, b cubed. Plus 70, a to the 4th, b to the 4th. Okay, minus 56, a cubed, b to the 5th. Plus 28, a squared, b to the 6th. Minus 8a, b to the 7th. Plus b to the 8th. There we go. And please circle answers so I can find them. There we go. Hopefully you've caught on. Like I said, homework is a handout. It will be on Progress Book after I'm still giving it to you in class, but if you lose it, I will make the key available in class so you can come on in and check. But make sure you ask questions. Okay, so if there's something that's not clicking, make sure you ask, because there is a quiz Monday over this stuff.